So good insight on that initial earthquake right this morning. And this is another visual from Lebanon, not too far from the epicenter. Let's talk about not only that one, but this powerful aftershock that was felt not too long ago here in the Northeast and the Mid-Atlantic. Let's bring in Princeton University geophysics professor. That's going to be Frederick Simmons. He joins us now over the phone. And Professor, thank you for being with us. Let's address that initial earthquake. Did you feel that? And can you kind of give us some insight about and details about what makes that occurrence so rare?
Well, very much so. I felt that I was doing work in my office, a massive building on the third floor, and it shook up and down and from side to side in a matter of, multiple seconds, 30, 35 seconds. And we all came out and thought that was an earthquake, and it was bigger than anything that we felt before. Bigger, notably, than the 4 years ago or so earthquake that we had in Freehold, New Jersey. It was not too far from where today's was. So we all immediately knew it was a relatively rare event, but not unprecedented. And now, of course, we just felt the aftershock, which was a magnitude of about 4 from the latest reports, a little bit away from where the first one was today. And I was on a different floor, but I still felt it. And this time I saw something shake, which I didn't see the first time.
And I want to ask you a little bit more.
Exciting times.
Yeah, exciting, right? Definitely not what we had planned for, your Friday throughout the entire day. Can we talk about the difference between these two? Because something I noticed right off the bat was the depth, right? That initial one was about 2.9 miles deep, right? Relatively considered a shallow earthquake. But this aftershock we just experienced was twice that depth. It was 5.8 miles. Is that considered deep at that point? Does that change the potential impacts? Like you had said, you actually saw something shake this time.
Well, it was a little bit further down into the earth, and so that relates to how much of the energy makes it up and at what, intensity. But I wouldn't read too much into the changing depths. I mean, some parts of some fault ruptured and slipped and relieved some stress, and it stands to reason that there's other patches of that same or a nearby fault that are yet to slip, and that's the several aftershocks that we felt. There was a 2.1 and a 2.0 and a 1.8, and now there was a 4, which is more easily felt by us humans at 30, 40 miles away. But I wouldn't read too much in the sense that it's going to be slightly different, and it's all still very shallow activity, which is why we feel it. That's not very down in the earth deep yet.
Okay, so since it's shallow, let's kind of talk about the nuance of East Coast versus West Coast. We know that the rocks are older here on the East Coast, and so it actually is felt at a greater distance, roughly 10 times the distance of what you could feel on the West Coast with a similar type magnitude. Can you speak to why that is a little more scientifically? Because all I can speak to is that it's older, but how does that change East Coast versus West Coast?
Well, so you look at the east coast of the United States and where it goes into the New Jersey shore, into the ocean, there really isn't anything significantly tectonically active until you reach the middle of the Atlantic Ocean. And that means we're on a passive margin. We're gently being pushed aside, and we've been stuck together to our ocean for a long, long time. And so there isn't very much force going on, very much stress buildup here. Unlike in California, where there is a massive plate boundary that runs near and at the surface that is actively pushing 2 entirely different plates past one another, and that's an active margin. And then a third type would be in a Japan setting or an Indonesian setting where you have 2 plates that are diving underneath one another tectonically. So geologically, geophysically speaking, our northeast is relatively placid, very quiet, but yet there are cracks in it, there are fractures in it, there are faults in it, and now and then they've accumulated enough slow accumulating stress to slip and break and cause an earthquake, and then another one until it will slowly die down in the next few days.
And so when we look at this type of event, I think it's impressive, what you just talked about, all of the factors that are overlaid when you're talking about different coasts here. And I think for many on the East Coast, this is something relatively unique or different for them. What kind of advice do you have for them when you're experiencing an earthquake?
Well, I think the thing that we train earthquake-prone area populations to do is to drop to the floor or somewhere where you cannot fall, to seek cover under something sturdy, and then to hold on to something fixed and stay there until the shaking and the rattling is gone. And so there are drills for that in the Pacific Northwest and in California, of course, in Japan and other areas where they're experiencing these things on a weekly or monthly basis. And so we couldn't have done very much, but I recommend that people look at what they would have done if it had been a larger earthquake. Where were your car keys? Was your door closed? Are you driving? Let's be aware of our surroundings, because the earth is alive and well. The earth is active. The earth is awesome. And we should not think that it can never happen in New Jersey. There will be a larger earthquake at some point, a little bit larger than now, nothing to really worry about. But we should be aware of what we can do in case the next one comes around.
Okay.
The other thing I recommend that people do, is to go fill out one of those reports that the United States Geological Survey collects, and it's called a Did You Feel It report, where us population, civilians can just fill out the questionnaire that says, I felt it this way and that way, because that helps us with hazard assessment and with disaster response and with historical seismicity interpretation.
And it's really crucial for us here on the East Coast because they'll give us a little more data. Plus, there's a massive population density here, so a lot of reports being able to come in. I do want to ask you something, too, real quickly before we let you go. I'm going to bring back up, there is the main earthquake that's just outside of Lebanon. That was early in the morning time, magnitude 4.8, 11 aftershocks so far. You notice how there's that cluster. When we anticipate these aftershocks in the coming days, as you had referenced, are we anticipating them to be in this region primarily because they're kind of married to the fault lines, or can they be felt in areas further south, maybe towards Virginia or the other spots in the mid-Atlantic?
Well, I think the seismicity is probably going to cluster to this area, but depending on whether the earthquake is a little bit larger or a little bit smaller, you're going to feel it a little further up and down the coast. But it's not likely to now suddenly go to a new center in Virginia, but it's likely to be in the same area where it has been occurring reliably every once in a while. Every few years we've had these earthquakes, and we had one in March, and that was much smaller. People didn't feel it, but this is not a dormant area, but it's not a particular dangerous or active area.
Such great insight. It's been a pleasure talking to Frederick Simmons. He's actually the Princeton University geophysics professor, sharing some great insight. Again, thank you for being with us here on Fox Weather.
Thank you.